All right, we're taking a look at indirect proofs, and specifically a proof by contradiction. And our first example reads, prove that if n squared is even, then n is also even. So let's start by saying what we're being given is we're being given that n squared is even. We know that that has to be true. And what we're trying to then establish is that n must also be even. Now, what's helpful, though, is that when you're doing a proof by contradiction is you're going to assume the opposite outcome and then hopefully force yourself into a contradiction or a statement that doesn't quite work with the previous goal. So let's assume then, just for the sake of our argument, that n is an odd value. So if n is odd, then what are we saying? Then n is equal to 2k plus 1 for some value k such that k is an element of the integers. All right, that works for me. But if n is equal to 2k plus 1, then let's examine what happens if we square both sides. So if we square both sides, what are we looking at? We're looking at 4k squared plus 4k plus 1. And what are we further looking at? We're saying that n squared would be equal to 2 times 2k squared plus 2k plus 1. Now, why is that relevant? Why would I want to write it like that? Well, in our previous problems or previous examples, we often have talked about how do we define something to be odd, as we say we're going to take 2 times some quantity and add 1 to it. Well, it looks like that we've done that right here. So it feels like we're heading towards our contradiction that we were hoping to create. So let's quickly define now. Let's say, let m be defined as 2k squared plus 2k. So we can rewrite this as n squared is equal to 2m plus 1. Now, what does this mean? It means that we have just said that n squared is odd. Now, why is that problematic? Well, to me, I feel like what we're trying to say two different things. We've created a contradiction, and I'm going to highlight them here for us. So let's zoom back out. Earlier, we said that n squared was going to be even, and what we just got done saying is that n squared is odd. That's our contradiction. Those two things do not agree. So what that means is our very first assumption that n is odd is false. Well, obviously, if something is not odd, therefore n must be even due to this contradiction. I hope that helped, and we'll talk soon.